the difference in approach really was, are you working against cement producers or are you working with cement producers? Are
Right.
you going to take advantage of the $3 trillion of existing Portland cement infrastructure in the world, or are you going to try to go out and create something completely new on your
hmm
own? And it was really not economic to try to just go out on your own and compete with the cement producer and try to disrupt this completely entrenched, really difficult to change industry.
Welcome to Manufacturing Insiders. Today I have Keith Krugh with me. He is the Chief Manufacturing Officer at Fortera Global. They are making some really big waves in the cement space these days, and their technology is really enabling cement to become a zero carbon emissions process, in addition to a lot of functional benefits of the material itself. Which is pretty impressive, because one thing that I learned from our previous conversations is that cement manufacturing is actually the largest contributor to CO2 emissions out of everything else. Isn't that right, Keith?
Yeah, it's up there.
Okay,
Depending on how you do the calculations, maybe up to 8% or so of global CO2 emissions from all sources.
gotcha. Well, at any rate, welcome to Manufacturing Insiders. One quick note. If you're listening to this podcast and you are a leader in manufacturing, you have insights to share, you have lessons learned, and you'd like to join the podcast, go to manufacturinginsiders.com, fill out the form there. Make sure you follow us on the different channels, LinkedIn, Instagram, subscribe to us on YouTube. Thanks a lot for that. But welcome to Manufacturing Insiders, Keith.
Thank you. It's great to be here.
Awesome. So, this episode I kind of see is going out to those companies, and I've talked to a lot of them lately where, they're making some pretty big innovations, but they're trying to break into a very solidified, mature space. And so I was really impressed with some of the techniques that you've been able to use to get in front of these companies and help them adopt your offering. So I just kind of wanted to throw that out there for anybody who just started listening to the episode. That's, who this is really going to be interesting to. But Keith, can you start with just a little bit of background on what you guys are doing and how it changes the process?
Sure. Fundamentally, Fortera is a materials technology company. And, essentially what we do is we make a cementitious product. It behaves a lot like Portland cement. So it's really and by Portland cement, I'm talking about the gray powder that basically is the glue that sticks concrete together.
Right.
So the company has come up with basically a way to produce this material with 70 to 80% less CO2 emissions than traditional Portland cement. And the process itself really just bolts on to existing cement facilities or lime production facilities, such that there's no interruption to their process, but they're able to actually provide a much greener product than their traditional cement production. So it's essentially an aqueous chemical process that takes CO2 directly from the emissions of a cement or lime plant stack, and it combines that with calcium to make a reactive calcium carbonate cement.
Okay. So I found it really helpful when you kind of explained the chemistry a little bit to me of kind of the way that it's done currently, and then what's different about this. Can you just describe that?
Sure. To make traditional Portland cement, you need to start with predominantly limestone. So limestone is calcium carbonate, and you take calcium carbonate, limestone from a quarry, you mine it, crush it down, and then you add about 15 to 20% of clay or shale aluminosilicate. So you have this mixture of limestone plus shale. You grind it up into a powder, and then you have to heat it up to about 2,700 degrees Fahrenheit. So it's a really heat-intensive process. You partially melt these materials together
Okay.
And then you take that product, you cool it off, obviously, then you grind it up again real fine, and that's what Portland cement is essentially.
Okay.
So when you do that process, you release almost a ton of CO2 for every ton of cement that you produce.
Wow.
Yeah, which is, it's part of it comes from the fuel. About 40% comes from the fuel required to heat the materials up to those temperatures. But 60% of this total CO2 emission from the process comes from the limestone itself, which is limestone's calcium carbonate, which is a mixture of calcium oxide and CO2. So it's actually mineralized, solidified CO2 until you heat it up. And that CO2 is liberated to atmosphere,
Okay.
and you get the calcium oxide remaining, which then combines with the other components in the shale to make cementitious compounds. So that's the Portland cement process.
I see.
Fortera's recarb process takes that same limestone from that same quarry at a cement plant or a lime plant. We crush it up, we heat it up, we release CO2 to the atmosphere, but we capture that exact same amount of CO2 that's released from the limestone back into the product to create the cement itself.
Very interesting. So the final cement, whether you're, making a pad or, a compound to join two bricks together, you're ending up with that limestone. Is that, that's what it is. Just you can form it now.
It sounds counterintuitive to start with limestone and then end up back with limestone, but that's essentially what we're doing. We're taking limestone, we're turning it into another form of calcium carbonate. It's a mineral called vaterite, and vaterite has the interesting property that it's cementitious when you add water back to it.
Okay.
So it's the same way that a coral reef is formed in the ocean. It's really the same material that corals synthesize that then immediately solidifies and turns into coral reef.
Interesting.
So it's the same kind of process.
So are there interesting underwater applications that this can be used for that maybe traditional cement couldn't? I don't, being that
it's kind of similar in that respect. And actually, traditional Portland cement also will harden underwater.
Okay. Yeah.
It's a traditional Portland cement solidifies and binds through a hydration process. It's a little bit different with Fortera's recarb process and the what we call react the product from it.
Yep.
In that it basically we're taking vaterite, we dissolve it, and then it reprecipitates as calcite. But the process is a little bit different. The end result is the same.
Okay. So in the early days of developing cement, where they realized that they needed to mix the limestone with the shale, I would assume at some point they said, well, let's try skipping the shale. Why didn't that work? What's different?
Yeah, so in order to make the cement compounds, really what you're doing with traditional Portland cement is you're taking calcium and you're combining it with silica. So really the main active ingredient in Portland cement is 3 parts calcium, 1 part silica. And that it doesn't form in nature. You have to artificially synthesize it, put the components together in the right proportions, heat it up to this 2,700 degrees Fahrenheit to make that reaction go. And then you've got something that's cementitious.
Yep.
So,
and then you need to add the CO2 back into it. That's why it wouldn't just work. Okay. Yeah, I kind of missed that at first. Okay, got it.
Yeah.
So, so what are the implications for the cement plants? And how have you been successful in getting them to kind of tack on this capability?
So really, I think there are a couple of primary, let's say, benefits or selling points, really, in that, a cement producer or a lime producer is really able to bolt this process onto their existing site, utilize CO2 from their own stack, utilize the limestone from their own quarry, which every cement plant and every lime plant in the world already has, permitted mine with reserves. And they're able to then expand their product portfolio into something like the, Fortera's React product.
I see.
So that's, it's essentially utilizing the existing infrastructure and, existing, like I said, the permitted mines, the processing equipment, the crushing equipment, the hauling equipment, the product silos, the entire logistics and sales network, things that are already pre-existing. It saves a lot of money
I can imagine.
capital expenditures, right? If you don't have to, to pay for that stuff at a greenfield site.
Right. Yeah, and you're totally skipping the shale portion of it. So what about the CO2 harvesting capability? I mean, I would assume that's a key piece of technology that you guys are providing.
Yeah, absolutely. And that's where the sustainable benefit is really in this process, right? Another piece of this that becomes interesting for a cement and a lime producer is that when you make Portland cement, the CO2 portion of the limestone that is released to atmosphere then results in a reduction in overall product, right? So if you start with 1 ton of limestone, you end up with about 0.6 tons of calcium oxide to go into your product. So you've lost 40% of your weight from your quarry to atmosphere. With Fortera's recarb process, you use 1 ton of limestone and you get 1 ton of product. Wow. So you're expanding your reserves in your quarry by 40%.
Right.
So it's, and that's huge when you start looking at, your quarries as an asset and how long is that asset going to last.
Right. Yeah. So let's assume your average cement plant, let's just say, to be cautious, let's say they were able to transition 50% of their final product to Fortera's cement. What would be their time to recoup the investment in, whatever they've had to buy to make this happen?
Yeah, so it kind of depends on what the sales price of cement is and those kinds of things. This is a little bit different from market to market, but this product, Fortera's recarb product, can be produced at the same or below traditional Portland cement pricing. Right. It's something that happens at standard temperature, standard pressures. It's an aqueous chemical process using easily attainable chemical components. It's nothing exotic.
Right.
And so it's something that's economically viable at the scale that Portland cement is produced.
Right. Yeah. I mean, obviously, you have a higher final output given the inputs, and you don't have to deal with the shale. So I can imagine that there would be pretty quick cost recuperation. Is it expensive for them to add this to their plant, I guess is what I'm trying to ask.
In terms of installed, dollars per ton of capacity, it's comparable to what a cement plant is. It's on the same scale as, if you were going to add capacity to your plant to make more Portland cement, it's similar. It's a very similar, dollars per ton of installed capacity. So it's really comparable to what they're already doing.
Right. So what's the downside? What's the pushback you get?
It's something that's new, right? And, this is a very risk averse industry, cement and concrete, and rightfully so. We're building structures that have to, support life. They're life-bearing elements, right? And it needs to be approached cautiously, seriously, scientifically, prove that it works. Let's make sure that what you're constructing with this new material is safe and will be resistant to, to the elements, whatever it may be, right? So I think it's, it is a matter of of proving things out. You got to kind of crawl first, walk, and then run. And we're in the stage of proving things out, demonstrating, showing people that this product works, showing that it's very resistant to chemical attack, more resistant than Portland cement in many instances. To things that are deleterious to Portland cement are not to this product.
Hmm.
Our product gains ultimate strength within about 2 days instead of 28 days, which is typical for Portland cement. So it's a very rapid strength gain.
Yeah.
Comparable compressive strengths to Portland cement, and very, very resistant to external environmental mechanisms that can attack concrete.
That's huge. Yeah, and then it's pure white too, so it looks cool.
Exactly. Yeah.
So in terms of, well, I guess since you guys developed the formulation and the process, how long has that been since you were ready to bring this to market at this point?
No, it's a great question. Fortera started as a company back in the early 2000s called Calera. So that the technology came from Calera. Many of the same scientists and engineers that were with Calera now are part of Fortera.
Right.
So we have this product in real world applications out there in driveways and sidewalks and buildings, really since about 12, 13 years ago. So
Okay.
it's, and we're able to take a look at those materials, study them, take a sample of them, check the strength, look at them microscopically, and be able to demonstrate that that nothing bad happens essentially using this material in construction.
Right. Okay.
So we've been around for a while, and that's a big benefit. And there were lots of learnings from that first company that has led us to the business model that we have today, to be a bolt-on, help to be a solution for cement and lime producers to diversify their products, provide sustainable building products.
Right. Yeah, and I would imagine that there's even beyond just like the immediate economic benefits and then the environmental benefits, you would also have some tax incentive. I mean, I would assume that there's some incentive structures for these cement plants to, become a little bit more environmentally friendly.
There are some, and as with any new technology, those help, to incentivize companies to take a risk on something that's new.
Right.
And that definitely is helpful in the early stages of a new technology.
Right. So in the original company, were you guys kind of thinking about this like, we're going to have people start up a new plant that would be focused solely on this technology, and that's where you kind of ran into barriers, and so then you kind of switched the model to making this an easily adoptable technology for an existing plant?
Yeah, that the difference in approach really was, are you working against cement producers, or are you working with cement producers?
Right.
Are you going to take advantage of the $3 trillion of existing Portland cement infrastructure in the world, or are you going to try to go out and create something completely new on your own? And it was really not economic to try to just go out on your own and compete with the cement producer and try to disrupt this completely entrenched, really difficult to change industry.
Right. So when you decided to attack it from that different angle, what were some of the challenges you ran up against? I guess what was like kind of the initial like, man, I'm not sure if this is going to work.
I think that really kind of the main piece of that was demonstrating that the product works. And how are you going to then market this? How is it going to be sold? Under what normative standards will it be handled? and so that it's kind of a process of having people gain confidence in the product that you've made, which is novel,
Mm-hmm.
And also demonstrating to the normative bodies that this works, and how can we add it into get it added into the standards so that it can be used, specified,
Right.
engineers can have confidence in it. So there have been many. We've had a sort of a multi-pronged approach to, let's get the material into some projects, some low risk projects. Let's work with the ASTMs and ACIs and get the product known and develop some confidence with people who are respected in in the industry.
Right. Yeah, and like you mentioned, being a life supporting structures in some cases. Um, the tough thing is that you do need that 15, 20 years, because even if it works right now, there's nothing to say that there won't be some sort of decomposition or whatever that was unexpected because of some sort of atmospheric condition. And so what is the timeline do you think you would need? Do you think that 13 years is acceptable at this point, or do you need like a 50-year window to really say conclusively this is never going to change and it's always going to be a great building material?
I think the scientific benefit of what this product is that it converts from the product converts from the mineral vaterite into the mineral calcite.
Mm-hmm.
So you're essentially making a network of limestone, and
right.
it's pretty easy to demonstrate what the stability of limestone is.
Right. We have a million-year case study.
Yes. And so it's from a scientific and engineering standpoint, we can demonstrate the 13 years that this product's been in service and nothing wrong with it. But we can also, from a common sense and understanding materials and geology,
Mm-hmm.
what is it that can actually change this? And the answer is, not a lot.
Weren't the pyramids built with limestone?
They're limestone, but not this particular cementing technology. Yeah.
Right,
Yeah.
of course.
Yeah.
Although it wouldn't surprise us if somehow they developed that back then. We still don't know what they're for.
Right.
So when you're talking about your sales process, how many cement plants are in North America? Do you have that number?
I don't. I've got, essentially there's maybe 110 million tons of installed capacity in the U.S.
Okay.
And some more in Canada, obviously, in Mexico, for all of North America. But I don't have the number of plants on the tip of my tongue. Most, if you can imagine, they're mostly about 1 million tons production each. Some are more, some are less, somewhere in there. So you're probably looking at 50 to 100 cement plants in the U.S.
So out of those, say 50 to 100, how many are actively using your technology?
So right now we have an agreement, or really a partnership with a global lime producer to essentially develop our first full-scale commercial plant. So right now we've got a small commercial plant that we have operating in Northern California, in Redding, and that's a 15,000 ton per year. Really, let's de-risk the technology, show that it works, get material out into real world big projects, and then we'll go for a 24x scale up from there. So that's what we're developing right now, with a global lime producer to put into place our first full scale commercial plant.
Okay. So the model of this being an add-on to an existing plant has not come to fulfillment yet.
Our small commercial plant in Northern California is bolted onto a cement plant.
Oh, okay, I see.
So the whole demonstration of how to do this, how to make it work, show that it scales. That's been done.
Gotcha.
Now it's a matter of, bringing this to, 400,000 ton a year production scale.
I see.
And we're also working with a number of cement producers for similar projects.
Yeah. Well, and I mean, in terms of diversifying your offerings as a cement plant, it seems to me that even just the use case of the cure time would be enough, that'd be justified in a lot of projects, So, I mean, it seems like it wouldn't be that hard of a sale just based on that, Like, I wonder, so are you actively reaching, well, you're not necessarily in the sales role as far as I know.
No, you're right. We wear many hats, but yeah, not so much.
Yeah. Okay. Now, I just kind of wonder what the approach was to get in front of these guys. Is it trade shows? Is it cold calling? Like, how do you go about that?
Yeah, it's kind of all of the above. There are many opportunities to speak at different conferences, which we do. I have lots of relationships in the cement business as well, just from having worked in it for over 25 years. So it's not so hard to really get in front of people and show them what you've got. And we've done this with really most of the cement majors. And yes, you're right. The 2-day curing time and the white color and all these things, it's generating a lot of interest.
Mm-hmm. Gotcha. Yeah, because it seemed like you guys were putting a lot of focus still on the proving side of things, but it also sounded kind of like you have proven it. So I was just curious why you aren't moving more aggressively to like get 50 of the 100 to add this onto their operation right now.
Sure, and it is a slow process, to make the whole thing happen. Yeah. Because the due diligence process takes quite a long time.
Sure.
And it takes time for people to get comfortable with, show me what your process looks like, show me what your economics are, where's the funding coming from, all these things, when the devil's in the details, the excitement is there, the clear business proposition is there. It just all takes time to make big things happen.
Right. So as the chief manufacturing officer, what does your day-to-day look like? What, are you making improvements to the actual equipment? Are you still looking at the material itself? What are you kind of doing?
It's some of all of that. Right now it's looking at, how do we streamline the process? What kinds of automation can we put in place? What kinds of, analytical techniques can we add to save time? And of course, what have we learned from the small commercial plant as we engineer the full scale plant right now? What kinds of things are we going to improve for process flow? What kinds of things are we going to be able to do at the full scale plant to maybe reduce capital expenditure? What can we do to improve, the operating expenses just from what we've seen so far? So it's working with engineering. Yes, it's working with products, and it's working with some end customers also. So it's a little bit of everything.
Yeah, and I would imagine it is a big opportunity to also sell yourself as kind of a technology company in addition to a new material that you're bringing to market. So I mean, if you're going to go into these plants and tack on equipment and operational capacity, you could also bring in that equipment for automation and sensors and the things that you should be measuring, all that sort of stuff.
Yeah, absolutely. It's all part of the job, and really the ongoing effort is to continuously make sure that this is an economic business proposition. The tech is really cool. I mean, the tech is amazing, but if all you have is really cool tech and it doesn't actually scale and it can't actually be done economically, it's not going to get much traction. So
right.
We're constantly focused on that.
what advice do you have? I mean, you're obviously applying some of these automation technologies in a unique, a unique use case. But for companies that haven't put a lot of thought into automation, data analytics, and gathering, do you have any advice, any lessons learned that you've experienced over the past couple of years?
Honestly, it's been from the last 30 years of working in cement as well.
Yeah.
And that, the more automation that you can put into a process, the more data that you can gather to know what's going on with your equipment, to know what's going on with your in-process product quality and final finished product quality. The more information that you have, the more efficient you can be, the more stable your process can run. And that at the end of the day turns into operating expenses. It's really the way to drive that down. And likewise with equipment monitoring, you can really drive down maintenance expenses as well. If you know what's going on with your equipment, you've got online, temperature and vibration and these kinds of monitoring systems. It's all money really, really well spent.
Gotcha. Okay. And are you who are you going to? Like, are we talking about sensors? What are you using to kind of measure some of this stuff?
Yeah, no, there are a number of different companies. Some of it's for in process, chemical measurements. What's my pH doing? What are my concentrations of different reagents? How are those changing? Gas analyzers. We're using CO2. So what's my CO2 coming in? What's my CO2 going out? All those things are important.
Yeah. Yeah. And that's, we talk a lot about that. In fact, I did a podcast earlier with, a guy that really focused on digital transformation for companies. And, we talked a lot about that process of gathering data, kind of picking those three big things that are when your manager asks, hey, let me know about the most important things. What are they, and how are you measuring them digitally? How are you recording them digitally?
Yeah.
So yeah, that's definitely good to hear.
Mm-hmm.
Well, I think that this is huge. I can't even imagine why a cement plant wouldn't want to bring this on board. It sounds like it's all wins and no losses. What do you see in the future of cement manufacturing? Like, how widely would you expect this to be used?
I honestly, like you said, I don't see a whole lot of drawbacks to doing this.
Yeah.
And I think starting with a bolt-on concept, with not trying to again compete with the cement industry, but to start with providing a wider range of products available. I think is a good strategy to start, and then I can eventually see this then replacing. Markets grow, right? Volume grows. As population grows, as developing countries develop, they consume a lot of building materials, and so as that process takes place, you can add capacity to basically maintain your market supply. So I can see that, and I can see also in mature economies that by bolting this on, you can start to replace actually your existing production in Portland cement. So
right.
I think the model fits well for both of those scenarios.
Right. Yeah, because I mean, if you bolt it on, and right now you're just using it for the use cases where you need that fast curing time, all of a sudden you're like, oh wow, I can produce 40% more final material for the same cost. Then you're going to your customers and be like, hey, you know what? You want a little better price on your on your product? And they're like, sure. So yeah, I can certainly see it be replaced. That's
as you mentioned earlier, it's also white.
Yeah.
And today the white cement market commands, huge premium. So there are real opportunities right there as well to expand your product portfolio and increase your revenue.
Do they have another way to achieve that white cement?
So the only way to do it with Portland cement is to utilize a very, very pure clay,
Okay.
which is usually kaolin, which is pretty
Yep.
expensive. So you have to mix kaolin with limestone and keep all of the iron out. That's
Gotcha.
what creates the gray.
Is it same as metakaolin?
It becomes that effectively.
Okay.
Metakaolin is when you take clay and you calcine it at maybe 8 to 900 degrees Celsius. So
Okay.
that becomes a supplemental cementitious material. In
Right.
this case, you'd be adding kaolin directly to your cement kiln, and it fuses and becomes part of the cement itself.
I see. Yeah, very fascinating. Just one other curious question. Given that the potential for this market is global, are you seeing any patterns, in global markets? Anything interesting that maybe you didn't expect? Like, are you going after a certain market because it's growing very quickly, or how much of an eye do you have on these global markets?
Yeah, I would say there's a lot of interest in Asia for this product. Especially because it's white. They're very interested in white cement products.
Okay.
I think there's a lot of potential for this also in Latin America, and we've got quite a bit of interest from that part of the world as well.
Mm-hmm.
So I think where demand is increasing is in the developing world, and so I think there's a lot of potential in those markets.
Right. Yeah, and I would imagine some of the war-torn country probably gonna be a lot of rebuilding in Ukraine, I would think.
Yeah, for sure.
So I like to wrap up with the general question of: do you have any needs right now? Are there any resources you've been looking for, whether it be some sort of a technology partner or a consultant of any sort? Is there anything that you've been kind of thinking about that you'd like, if somebody was listening, they could reach out?
Yeah, we're always looking for interesting projects to be involved in for case studies. We have sizable volumes that we can produce, but we don't have our full scale commercial plant operational yet. So we're always looking for people who are interested in doing projects that we can showcase, we can jointly promote and develop.
Yeah. Okay. Yeah, that's interesting. Oh, that kind of reminds me of another question. So when you're actually transporting the cement, in a cement truck, is there any difference there? Is it setting up faster? Like, do you have any additional concerns with?
If it's like in the actual concrete mixer truck,
yeah,
the setting time is about the same as Portland cement.
Okay.
And it can also be kind of manipulated. So
right.
It's a little bit easier to control in some ways than Portland cement.
Oh, okay. Good. Interesting. Well, hey, Keith, thanks a lot for coming on. We got to learn about something innovative, and we're probably going to be seeing a lot more, white roads and structures in the future here, which is cool.
Yeah. No, thanks a bunch, Nate. Appreciate it.